Hello, welcome to AC's 8-Bit Zone. I just received a package in the mail this week and it contains the first prototype boards of CoCo digital video. The PCBs were manufactured at JLCPCB and I used their assembly service to place most of the surface mount components on the boards. So today I'm going to open the package, check out the boards, apply power, and just see how far I can get with checking these boards out and bringing them up. So we'll start off by opening the package and then we'll see where we go from there. So let's open the package and see how the boards look. I don't know if the CoCo digital board is going to fit into this model of the CoCo 2 or not. This is one of the early Korean models. And so I'm going to remove this breadboard where I have an S-Video mod going on. So it's modded for S-Video, and I'm going to remove the breadboard and just try fitting CoCo digital video in place in the 6847 socket. So to do so, I only need to desolder a ground wire and remove a couple of pin headers from the breadboard. Okay, breadboard is out and the CoCo digital video board is in place. It fits, so that's a good thing. So the edge of the board comes really close to the keyboard ribbon. That's okay. And there's enough clearance back here at the cassette recorder relay. So yeah, plenty good board height. It's actually very stable in the socket. So good so far. Now I'm going to do power on checks and see if the internal board power supplies come up properly. Okay, hopefully we have some good luck here. There it goes. Okay, the board should supply power on pin 17. That's our 5-volt supply. And here we go. Okay, this should be 5 volts at the regulator. Okay. And then the middle leg is going to be 3.3. Okay, this is the 2.5 volt regulator. So that must mean this one is the 3.3. Okay, 3.31. And then this would be the 1.2 volts. 1.206. All right, good. So that's a great first step, that the power supplies came up properly. Okay, I think the next thing that I want to do is see if I can connect by JTAG and talk to the FPGA chip. Alrighty. Okay, I'm going to connect this JTAG cable and let's see if I have any good luck, or what kind of luck I have. Okay, we're in the programmer. This is the Quartus 2 programming tool, and this next step is going to tell us a lot. If I click on auto detect and it brings up a menu of device selection, then that's a great sign it's detected something. And then if I select the correct chip and it brings up the FPGA symbol over here in the right hand panel, then that's a great sign too. So here we go. Let's see, is the CoCo powered on? Okay, yes, CoCo was still powered on, and here we go. That's a good sign. Okay, so this is the EP4CE10. Great. Okay, so it detected the device and it's indicating that it thinks that it has a JTAG connection. So, well, of course it's going to be blank, but okay. So, I don't know, why not just, let's just go for it here. Let's just try programming it. Program configure. Let's go. If it works, it'll be quick. Okay. Hey, one of the LEDs turned on. And do I have that on camera? I hope you could see that on camera. Yeah, one of the LEDs turned on. That's LED 1. And honestly, I don't recall if that was supposed to turn on or what. Cool. Okay, so it programmed that. This is the first of the prototype boards of the CoCo DV, and so we were able to power on its power supplies. They're all good, and the JTAG connection is good. We were able to program the FPGA, and looks like we're able to turn on one LED. So, very good. If I press the reconfig button, I think it's going to lose its image. Yep, okay, it loses the image, and I can program again, hopefully. Yep, LED came back on. Okay, good. So I need to go check and see if I thought only one of the LEDs would turn on, or both, or, you know, is one LED placed backwards and they're supposed to both be on? Who knows? Anyway, this is a good first sign. Okay, the next thing I want to do is get the CoCo DV back out of here, and I'm going to place the VDG socket and solder it into the top side of the board here, and then I can put the VDG chip in socket, return this to the board, and move on from there. Now I don't have the HDMI connector placed yet. That would go in this corner. I'm waiting for a hot air rework station to come in to get shipped in. So I won't be able to test HDMI for a while yet, but I will probably go ahead and populate this TFT LCD header, and I can test with my little 2.8-inch TFT display. Oh yeah, I just happened to think I want to see if I can also program the serial flash. And go ahead. It takes a little bit longer to program the flash than to just program the FPGA itself. This seems about right. Right. Okay, it seems to have programmed it. Now, if it has the correct program in there, the same program as what I loaded by soft file a moment ago, then when I press the reconfigure button, it's going to load this new image from flash. And by the way, the flash chip is the one over here in the right hand corner. Okay, let's try reconfig. Okay, that same LED came on, so good news. The serial flash is also functional. Good to go. Okay, now I'm going to get back to adding the socket to the top side of the board. Okay, I've socketed the MC6847, the VDD chip, and powered the CoCo DV back on, made sure that everything looked okay. Now I've wired up the little TFT display, and I'm going to apply power, and hopefully we get display. Oh, good. Excellent. Oh yeah, looks good. All right. Well, let's heck, we could even see. Let's see if we can play a game on here. Hold on one second. Okay, here's what I have. I had to get some helping hands out here to hold the little display. And again, this is a SPI connected display, and it's just for development purposes and for moments just like this when maybe I don't have the DVI cable connected yet. So my new board doesn't have the display connector soldered on yet. So this display has a slower update rate because it is coming over the SPI type of a connection. That's a serial peripheral interface. It's a 4-pin serial interface. So yeah, so, and looks like it's a little bit flaky. I didn't see any signaling problems with the shorter wires in the breadboard, but it could be that either I'm running the SPI clock too fast, or these long lead wires are just too much for the signal. But looks like I'm basically getting enough of the signal that I'm getting the display most of the time. Looks okay. So this is going to be good enough to get started with. Okay, so I'm going to play a couple of games. I'm going to play Dragonfire and I'm going to play Canyon Climber. Let's start with Dragonfire. Okay, starting with Dragonfire. Yeah, there's definitely a little bit of a signal problem with these long SPI wires, but we'll go with it as best we can here. Okay. Yeah. Looking pretty good. All right. Okay, that's pretty good. Let's play another game. Let's play Canyon Climber. Okay. Okay, Canyon Climber. Okay, I think it's the other joystick for this game. Yes, definitely. So like I said, I'm seeing some glitches now and then, and for the moment I'm attributing that to the SPI wiring. I don't think it's going to deal with those longer fly wires as well. And I'll probably double check that later by lowering the clock rate on the SPI. And then, I can see if it's just a speed versus wire length problem. And I'll be really excited to get that video connector soldered on. So I can start bringing up the actual HDMI or DVI signal. While we're here in an artifact-based graphics game, we can try. I haven't tried the push button that changes artifact modes. So let's try that push button for the first time. Okay, it works fine. So we're going to be toggling through the 4 different artifact modes. So we were starting up there in so we're starting up there in rich artifacts. This is monochrome, black and white only. And then we have simple artifacts where there are only two colors being simulated here. Or I believe this is double wide bits. And then back around to the rich artifacts. Oh yeah, and this is an earlier version of my, yeah right, this is an earlier version of the FPGA. In the latest version I've added, it's actually 8 modes because there's a color swap that's, because of the color swap you can swap the blue and the orange. So in my latest version of the FPGA that cycles around through 8 different selections for artifact mode. So this one has just the blue set as the defaults. Okay, but it has rich artifacts, and like you could even see here where the little sticks of dynamite are showing up sort of with a pinkish color. And then there's some other spots here and there. It's too small to really see on this display, but you can see it on the full-size monitor. You can see some little bits of green here and there, and there's some yellow showing up in the trussels of the bridge. Then we cycle over into monochrome. Now in simple artifacts, the pink sticks of dynamite are white, and if we pick up the dynamite, it should turn black. Okay, yeah, or sort of, it goes to sort of a see-through appearance after you pick up the sticks of dynamite. Let me get the safety here so I can talk again. Okay, and then, so just cycling on around. Then we're into double wide bits, and then back to now back around to rich artifacts. All right, great. Well, so far I'm really happy with the way this board is coming up, and more work to do. And I'll have more videos coming up soon on CoCo Digital Video, so stay tuned for more updates coming your way. And once again, thanks for watching, and until next time, see you then.